All right, let's talk about standard form of a quadratic function today. Standard form, I realize this is a lot of information here, so let's just cover some of it up. Standard form is just a very specific way of writing the quadratic function as an equation. And it's when you have this quadratic, remember it's quadratic because it has x squared in it, in standard form. Just like when we talked about standard form of a polynomial, that quadratic is written in standard form with the term that has the highest exponent, the x squared goes first. In the middle, you have the term that has x to the first power. And then at the end, you have that constant term that does not have any x's attached to it. Okay, when an equation, a quadratic equation, is written in this form, we have the coefficient of x squared is what we're calling a for the notes for today. B is the value in front of the x term or that linear term. And then C is the constant value, the constant term. So if your equation ends with plus 5, C would equal 5. If your equation ends with negative 6, C would equal negative 6. And those numbers, A, B, and C, actually tell us a lot about the parabola itself. And that's what we're going to look at today, is understanding what can we do with the values of A, B, and C to help us figure out the y-intercept, the vertex, the axis of symmetry, and other things like that. So first and foremost, A, the value of A actually tells us if the parabola opens up or down, which in turn would also tell us if there's a minimum or a maximum. Because if the parabola opens up, then it has a minimum value. Because remember, if it opens up, it's going to look like this, except for maybe more rounded at the bottom. But there's going to be a lowest point on that parabola being the minimum. Okay, and that's going to happen anytime if that value of A is greater than 0. Okay, in other words, if A is a positive number, so if the x squared term is positive, then our parabola is going to look something like this. We know it's going to open up, there's going to be a minimum. Now, the opposite of that is also true. So if A, or the x squared term, happens to be negative, whether it's negative 2x squared or just negative x squared or negative 1/3 x squared, but if that value for A is less than 0, meaning it's negative, then the parabola is going to open down. And any parabola that opens down would then have a maximum at the top, a highest point on the parabola. Okay, so all parabolas that open up have minimums, all parabolas that open down have maximum. And that is all dependent on this value out in front as the leading coefficient of the quadratic. Okay, has to do if A is positive or negative. Now, the y-intercept of the parabola will always be the value of C. Well, think about it. If the the y-intercept is always going to have an x-coordinate of 0. Okay, we've seen that before. We've seen that with linear equations. So in that case, if x equals 0, what's going to happen to our quadratic? Well, it's going to become 0, sorry, not 0x squared. It's going to become like 0 squared plus 0 plus c. Well, 0 squared plus 0 plus c is literally just c. So if x has to be 0, then c, that number at the end, that constant term, is going to be your y-intercept. That's the value of the y-intercept. As an ordered pair, we write it as 0, comma, and then that number. Next is the axis of symmetry. Now, the axis of symmetry, we actually use this formula to calculate the number. You'll recall from a previous lesson that the axis of symmetry is that vertical line that goes right through the middle of our parabola. It splits the left side and the right side apart. It makes them mirror images of each other. There's the symmetry on the two sides. So that vertical line is always going to be just x equals a number. Now, if we don't have the graph to go by, and all we have is this equation in standard form, we literally take the value of b, and we look for the opposite of that value and put it in the numerator. And then we do 2 times whatever the value of a was in the denominator, and divide if you can divide, or write it as a fraction if you can't divide. And that is the number in our axis of symmetry equation. Now, as we saw in the previous lesson, that number from the axis of symmetry is also going to be the exact same number as the x-coordinate of the vertex, because, the axis of symmetry goes right through the vertex, so they share that x-coordinate in common. And then to find the y-coordinate, this is really more like evaluating polynomials. So we saw this f of whatever that number is. We're just going to evaluate for that value of x. If x equals 2, we plug 2 into the quadratic and try to see what it equals. But that'll make a lot more sense once we start looking at an example. All right, so let's take a look at our first example. All right, starting out with, it just says, what are the values of a, b, and c? So I see my quadratic equation up above. It's in standard form because everything goes in order based on the degree. So I have 3, let me try that again with the highlighter. There we go. 3, -6, and +1 are those 3 values. So a equals 3, b equals -6 because of the subtraction there, and c equals +1. So let's use what we know to determine these 5 things. Does it open up or down? Does it have a minimum or maximum? Find the axis of symmetry, the vertex, and the y-intercept. So let's start with the number 3. 3 was the value of a, and you might recall from our notes, a will tell us if the parabola opens up or down, and also then if it has a minimum or a maximum. It all has to do if a is positive or if a is negative. So in our example, we see that a is a positive number. Okay, so when things are positive, it's going to graph a smiley face. Positive things are good things. It makes us want to smile. So this is going to open up. And because it opens up, just like in our example over here, there's not a highest point because it keeps going up forever, but there is a lowest point, which means there will be a minimum y value. So it opens up and there's a minimum because a was greater than 0. A was positive. All right. Next easiest, I think, is actually the y-intercept. Let's jump to that. Remember, the y-intercept is when x is 0. So in our equation, if we do 3 times 0 squared minus 6 times 0 plus 1, what would that give us for a y value? Well, that's 0, that's 0, and that's 1. 0 minus 0 plus 1 is just 1. It's just going to be that number at the end. So my y-intercept when x equals 0, y equals 1. All right, next, the hardest part of this is using that formula for the axis of symmetry. X equals -b over 2 times a. So let's plug in what we know. Well, we know that b is actually a negative number to begin with, so b is -6. So when I plug this in, it's like -6. I'll just leave it like that for now. In the denominator, I'm supposed to do 2 times the value of a, and in my equation, the value of a was 3. So let's simplify what we can. In the numerator, that double negative is going to become a positive because the opposite of -6 is +6. In the denominator, 2 times 3 is also 6. And since we can divide that out, we go ahead and divide it out. 6 divided by 6 is 1. So my axis of symmetry is at x equals 1. Now for the vertex, my coordinates of the vertex also include that exact same number as the x-coordinate. To find the y-coordinate, I just take my equation, and I'm going to say y equals instead of that f of x. And I'm going to write everything else down and leave a big space everywhere there is an x. And we are going to use our x value. So we solved just moments ago that the axis of symmetry was at x equals 1, which means the vertex has an x-coordinate of 1, which means x is 1 in this equation when I do this. So I have a little bit of math to do. You could use a calculator, but 1 squared is 1, and 3 times 1 is 3. 6 times 1 is 6, and 3 minus 6 plus 1 is -2. So the y-coordinate of the vertex is at -2. Now let's check this and let's see if this is accurate. So we're going to go to Desmos and we're going to type in our equation. We'll just use y equals instead of f of x equals, even though this is just function notation. So I have 3, -6, and 1. Let's see if I can remember that. So y equals 3x squared minus 6x plus 1. Now I see I have my vertex at the bottom at 1, -2. Is that what I had here? Vertex 1, -2. Awesome. My y-intercept was supposed to be at 0, 1. Let's check. Let's see, it crosses the y-axis right there, 0, 1. We also see that our parabola opens upward. The arms are extending upward, which means there is a minimum, a lowest point at the bottom. So opens up and minimum. Let's check. Opened up, minimum. Perfect. We check the axis. Oh, we didn't check the axis of symmetry. If I do this and just type that equation, x equals 1, I notice that it is that vertical line that goes right through the middle of the parabola, also right through the vertex at that 1, -2. So everything appears to make sense with what we have here. All right, let's try again. This time our equation reads g of x equals -x squared plus x minus 4. So the value of a, I don't see a number there. All I see is a negative sign. I wonder what that could be. Well, hopefully you remember that a then is -1. B is +4. C is -7. Notice I just take the numbers right out of the equation. Now, since a is a negative number, that means a is less than 0. That means my parabola is going to open down. And because the parabola opens down, it has a highest point, a point that it never goes above. So it actually has a maximum, not a minimum. My y-intercept, remember where to find the y-intercept of the equation? It's always that value of c that appears at the end. Okay, so we've got -7 is the y-intercept of this one. We're going to write it as an ordered pair though, 0, -7. And the hard part, that axis of symmetry equation. It's not just a single number up there, it's a combination of a couple of numbers with this formula. So the opposite of b divided by 2 times a. So let's look at it. The opposite of b. Well, b was this number in that middle term, so +4. So the opposite of +4 is going to be -4. In the denominator, I'm supposed to take 2 times the value of a, and we said a was -1. So we had -4 on the top. We multiply to get -2 on the bottom. And when I divide two negatives, I get a positive. So x equals 2 is my vertical line, the axis of symmetry. So next I want to find my vertex, and I'm remembering my x-coordinate is going to be the exact same number as that axis of symmetry number. It's nice that it works out that way. Then the only other thing I have to do is plug that in. Right after we evaluate my function, evaluate g of x, you know what, let's go ahead and even write it out that way, when x equals 2. So I had -x squared plus 4x minus 7. That was my equation up above. Oops, except I want to make that x blank because I'm going to plug a value in there. We said x equals 2. We're going to do a little bit of math. The negative sign stays there. I apply the exponent first. 2 to the second power is 4. 4 times 2 is 8. So -4 plus 8 minus 7 is, well, let's see, -4 plus 8 is 4. 4 minus 7 is -3. So g of 2 equals -3. In other words, the y-coordinate of my vertex is -3. So there we have everything, but let's check. Let's just use Desmos as a way of checking, just to be certain that we're doing it right. All right, so my equation. Sometimes it's hard for me to remember the whole equation, but if I can remember 3 numbers, I can write that equation. I just have to change those values for a, b, and c. So -1, 4, and 7. -1, 4, and 7. All right, so -1, positive 4, and positive 7. All right, so there's my parabola. Zoom out a little bit so I can see it better. All right, my vertex. Something's not matching. Oh, negative 7, not positive 7. That's where I messed up. Whew. I thought I did something else wrong. There it is. There's my vertex at 2, comma, negative 3. If we double check what we solved here, yes, it is at 2, comma, negative 3. Our y-intercept should be at negative 7. Let's check that. Y-intercept, there we go. Yes, 0, comma, negative 7. We can see our parabola opens down. Therefore, it has a highest point, a maximum. So opens down and maximum. Opens down, min or max, maximum. So check, check. We check the vertex. We check the x-intercept or y-intercept. The only thing we should double check is our axis of symmetry. Let's type that equation, x equals 2, in here and make sure it goes through the vertex. Our line goes through the vertex. Look at that. Of course it does. Very good. Goes right through the middle of the parabola, right through our vertex. Awesome. So everything is matching up. All right, one more example, then we'll be done here. Try to find the values of A, B, and C on your own. All right, I hope you notice that because it's 2x squared, A is 2. Because it's positive 20x, B is 20. And because it ends with minus 5, C is negative 5. All right, so how about, does it open up or does it open down? Well, since A is 2, in other words, since A is a positive number, the x squared term is a positive x squared term, it is going to open up, meaning it looks like this. So is there a maximum or a minimum? Well, if it opens up, there's a lowest point. That means it has a minimum. All right, let's jump down to y-intercept. What's the y-intercept? Well, I see at the end of the equation, it ends with minus 5. So my y-intercept is 0, comma, negative 5. Next is the axis of symmetry. I already know it's going to be an equation, x equals something. And we use that formula, the opposite of b over 2a, to get that number. So let's substitute what we know. All right, so the opposite of b, well, b was 20, so the opposite of that's going to be negative 20. In the denominator, we do 2 times a. A was also 2, so 2 times 2, which is 4. So negative 20 divided by 4 is negative 5. My axis of symmetry is that vertical line, x equals negative 5 when we graph it. Okay, last thing is the vertex, then we'll check it. What's the x-coordinate of the vertex going to be? What number goes in this first spot? That's right, it's the first number, or the same number from the axis of symmetry. It's negative 5. Last thing we need to do is substitute that value, negative 5, into the function. So h of negative 5 equals, let's see, it was 2x squared, so 2 times negative 5 squared, plus 20x, so plus 20 times the value of x, and minus 5 at the end. Just rewrote my formula, my quadratic equation, and placed negative 5 anywhere there was an x. Well, let's go ahead and do a little math here. Remember to do the exponent first, so I don't want to do 2 times negative 5. I want to do negative 5 times negative 5 first, which is 25, and 2 times 25, which is 50 for that first part. 20 times negative 5 is negative 100 plus negative 100, or you could say minus 100 there, it's fine. And then minus 5. So 50 plus negative 100 minus 5 is negative 55. Let's check it. Let's plug it into Desmos and see how we did. Because that seems like a pretty small number, negative 55, to be the vertex. That's a really low minimum, but let's check. Maybe it is. So my values that I need to plug in are 2, 20, and -5. Let's see if I can remember them this time. 2, 20, -5? Is that what it was? 2, 20, -5. Yes. All right, so let's look at our equation. Zoom back out. Oh, man, what's going on? Zoom way out, way out, way out. There it is. All right, my vertex. Remember how we said it was really small, really low? Click on my line. There we go. My gray dot appears. All right, look at that. My x-coordinate's -5. My y-coordinate's -55, and that's the vertex, the lowest point. So we did get the correct vertex. Because it's a lowest point, it's a minimum, which means it opens up. My axis of symmetry should be the correct number because my vertex started with -5. We could certainly double check by writing x equals -5 in here. Yes, we get that vertical line that goes right through the vertex. What are we missing? Y-intercept. Let's move this up. I'm going to go up quite a ways before it crosses the y-axis. Suppose I could have zoomed out first. If I click on my parabola, I'll get the gray dot so I know exactly where it is. There it is, 0, -5. Hey, look at that. My y-intercept was 0, -5. We did it. We got everything right. All right, we're ready to practice.